chapter 10 we start getting into trig, and 10 is mostly about dealing with radians. And the conversion for them is multiplying by pi over 180 or by 180 over pi, going back and forth. And on page A5, I want to make sure that you definitely fill those tables in so that you are familiar with the conversions for certain angles, if you aren't already familiar with those. If we have a circle and we know a central angle, in radians we can use the two formulas shown here. L stands for arc length, A stands for sector area. So if I want the arc length and sector area in a circle with a radius of 12 and a central angle of 65 degrees, I don't know what that symbol is there, but to find the arc length, we're going to take 12 times, not 65 because we need it in radians, but we can take 65 and multiply by pi over 180, and we will get how many centimeters our arc length is. And similarly for area, we can take 1/2 times 144 times our angle measure in radians and get some number of square centimeters. Some identities, and these are in your formula pack. Tangent is equal to sine over cosine, and sine squared plus cosine squared equals 1. This is the Pythagorean identity. And we're going to be talking about the unit circle meaning that the size of it is equal to 1, the radius that is. So there's a circle. It's centered at the origin. And the radius on this circle, that is 1. And we can think of it any point on this circle as A comma B, some XY pair where this is X or A and this is B. And that could be our angle in there. So what this problem is asking us to do is it's asking us to take any angle, like I have drawn here, and add on pi over 2 radians. So for those of you degree nuts out there, that's adding on a 90-degree angle, which would be like that. So that purple terminal side is representing pi over 2 plus theta. And we can think of this as a triangle also. And essentially all we've done is we've rotated that initial green triangle 90 degrees. So here, that side of the triangle is B, this side is A, and since B is going to the left, this ordered pair up here would be negative B comma A. So, the deal with the unit circle is that all ordered pairs are given as cosine theta comma sine theta. If we look down here at angle theta, sine is opposite over hypotenuse. Sine would be B over 1, or just plain B, which is the y coordinate for that angle. So the cosine of our purple angle is negative B. The sine of our green angle is B. The two sides are indeed identical. Find the possible values of cosine given that sine is 2/3, and we want to illustrate this. So here's our circle. There's our origin. And we want the sine to be 2/3. In other words, opposite over hypotenuse to be 2/3 in a triangle. That could happen in the first quadrant here. Opposite being 2, hypotenuse being 3. Or we could also have a triangle in the second quadrant in the same scenario. Opposite is 2, hypotenuse is 3. The difference here is the adjacent side. And we can use the Pythagorean theorem to find that. The square root of 9 minus 4, in other words, the square root of 5. So using SOHCAHTOA, the cosine of theta either is going to be the square root of 5 over 3, or the cosine of theta will be negative square root of 5 over 3. That's one way to solve this graphically. What we could have done would be to use the Pythagorean identity. And we can plug in 2/3. So sine squared is going to be 4/9. Which means the cosine squared of theta is going to be equal to 5/9. If we square root both sides, cosine theta is plus or minus the square root of 5 over 3. Same answer, more of an algebraic approach though. Similar problem, but we're told now that the angle theta has to be between pi and 3 pi over 2, which is the third quadrant. So what we're going to do is we're going to draw ourselves a triangle in there. And we're going to use the information given to us that this is opposite over hypotenuse. So opposite side negative 3, hypotenuse 4. Hypotenuse is always positive. And now we can find this other side here. Square root of 16 minus 9, or again, square root of 5. And because we're in the third quadrant, this side has to be negative. We're going left. So cosine theta is equal to negative square root of 5 over 4. Again, we could have used the Pythagorean identity, choosing positive or negative when we square root as appropriate in this problem. Since we're in the third quadrant, both the sine and cosine need to be negative.